Hi everyone, and welcome to our next tutorial. In this one here, we're going to take a look at something that may be brand new for you if you're in grade 11. Grade 12s might have seen this before. I'm going to take a look at a circuit here. It's a parallel circuit, but we have something that looks brand new, and that is this thing right here. So typically when we think of circuits we've looked at before, we look at a DC source and the symbol for a DC source, and that is the symbol for a battery, which determines the voltage. But this symbol right here is actually what we call a current source. And when we have something like this, we're not stipulating what the voltage is, we're stipulating what the current is. So we could say that this source is putting out, say for instance, 6 amps of current. And we're not given the voltage, but we know that 6 amps is coming out of that source. In this case, we're saying 6 amps is coming from the current source. We should be able to figure out then what's the current flowing through the branches. If the branches are all the same resistance, then we know that 2 amps of current is going to go through each branch. So if all of these resistors are the same, I'm going to get 2 amps going that way, 2 amps is going that way, and 2 amps is going that way. If they have a different resistance, then that current is not the same through each one of those resistors. And we can actually determine what the current is using this formula right here. The current going through any resistor is equal to the total current multiplied by the total resistance over that resistor value. So before we can use this formula, we need to know the total resistance. Well, it's a parallel network. So let's find it for this circuit right here. We're saying that R1 is 10 ohms, R2 is 20 ohms, and R3 is 50 ohms. So given that, we should be able to find the total resistance, and we can do that with this formula right here. So 1 over R1 plus 1 over R2 plus 1 over R3. So that's 1 over RT equals, so R1 is 10, so that's going to be 1 over 10. R2 is 20, so that's 1 over 20. R3 is 50, so it looks like this. If I go carry on up here, I can find a common denominator if I wish, or I can convert two decimals. I'm going to find a common denominator of 100. So if I change 1 over 10, that becomes 10 over 10. 1 over 20 becomes 5 over 100. And 1 over 50 is the same as 2 over 100. So it looks like this. So 1 over RT equals, add them together. Now I've got a common denominator of 100, so I can add them together, and that comes out to 17. So I get 17 over 100. If I want to figure out RT is equal to 100 over 17. Take your calculator. That doesn't come out even. So take your calculator and figure that out. So 100 divided by 17 gives you 5.88. Now be careful with our rounding errors here. So 5.88 ohms is the total resistance of that circuit. B says if the current source is 6 amps, what's the current going through R1? So let's take a look using our formula here. So the current going through that resistor, resistor 1, is equal to the total current multiplied by the total resistance all over that resistor value, which is R1. So plugging into this formula, I1 is equal to, well, the total current is given as 6 amps, multiplied by the total resistance, which is 5.88. I'm going to take one more decimal place. I'm going to take 5.882 ohms and divide that by the resistor value. R1 is 10 ohms. So it looks like that. So now take your calculator and we'll do inside the brackets first. Figure out what that is. So 5.882 divided by 10 equal to, and then multiply that by the total current. And it comes out to, I'm going to take it to 2 decimal places, 3.53. So that's 3.53 amps of current going through that resistor. Now, does it seem to make sense? Well, that is the smallest resistor. That should get the most current. So you can see that that's over half the current is going in there. Let's move down and take a look at the next one. Let's practice using this formula here. And for this one here, I2 is equal to, using that same formula, I'm going to plug in. So that's 6 amps times the total current, the total resistance, 5.882 ohms, divided by that resistor value for R2. Well, R2 was 20 ohms, if you remember. So it looks like this. So again, take your calculator, 5.882, and divide that by 20 this time, equal to, and times by the current, 6 amps. And that comes out to 1.76. So that's 1.76 amps of current. If we look at the last one, what's the current going through that third resistor? That's going to be 6 amps times the total resistance. So that's in ohms, divided by that resistor value, which was 50 ohms. And let's see what this works out to. Grab your calculator. 5.882 divided by 50 equal to, times by 6 equals 0.7. If we round, we'll say 0.71. So 0.71 amps of current. And that should make sense because that is the biggest resistance. The biggest resistance should have the smallest amount of current. Now, if I just scroll down here, just give myself a little more space here. This should check in terms of KCL. KCL is saying that the total current in this circuit should be equal to the sum of each current going through each branch. So that's I1 plus I2 plus I3. So in other words, the total current we were given is 6 amps. That should be, if everything checks out, equal to 3.53 amps plus 1.76 amps plus 0.71 amps. We're trying to see, does the left side equal the right side? Grab your calculator and just check that to see if that makes sense. 3.53 plus 1.76 plus 0.71 equal to, comes out to exactly 6. So right side equals left side. So there we go. We learned how to use a formula for current dividers. So use that formula there to figure it out, and that should help you with any other problems. If you have any questions, just come and see me. That's it for this video. Thanks, and see you next time.